In this lesson, we're going to cover how to create and drive an assembly constraint. An assembly constraint that's driven basically is going to add motion. What we're going to start off with here is the drive constraints.iam file, which can be found in your Chapter 6 exercise folder. And what I'm going to do is apply a couple assembly constraints. The very first one, let's place in an insert constraint just to align up our two hinges here. And just to show right now that that second hinge can definitely move. And what I'm going to do is I'm going to place in an angle constraint. So I'm just going to reorient this screen here a little bit. Just hit C on the keyboard and let's place in an angle constraint. In this case, I'm going to drive that angle constraint. So what you're probably familiar with so far is we could go back and you can edit that angle constraint. So I could go back and type in 25 and the hinge will change to 25. But really what I want to do is I want to run that through a range of motion. So what I can do is right click on that angle constraint, click on drive constraints. Now in the dialog box we can go back and type in some information. So in this case let's drive it from -45 to 0 degrees. And then we can go ahead with our VCR like keys. Let's spin the screen around here so we can look at it a little bit better and drive it forward and backwards. If you expand the dialog box, we have a couple different options here. So we could drive it with the adaptivity if your assembly had adaptivity on. We could do collision detection, and with collision detection is it's running through its range of motion, and if it does find some collision it will stop right there, and right up on the top here where in this case it says -45, it'll tell you that's where the collision occurred. Down at the bottom part here you can also change how the angle constraint in this case is going to be driven. So right now I'm going in 1 degree increments, total number of steps. So if I wanted to I could just say let's look at it in 15 steps. And let's drive that forward. You can see kind of choppy, so in this case I'm going to place it back to 1 degree. And the total number of repetitions right now it's just doing 1. Let's change that to 3. You can see what it's going to do here is it snaps right back to where it was, because right now I'm just doing start end. I can change that to start end start, where now it's going to go back and it's going to be nice and smooth on the way up and also on the way down. You can also go back and you can record this out to a movie file. So by clicking on the record you're going to get some options to pop back up, and it'll ask you, do you want to record this as an AVI file or a Windows media file? So right now I'm just going to cancel out of that, and I'm going to delete that second plate here. And what I want to do is just drop in another plate. And what I want to show here is that there are a couple different options that we can do for driving the constraints. It doesn't have to just necessarily be an angle constraint. For the next portion of the exercise, what we'll do is let's go back and apply a mate constraint to two planar faces on our hinges. And we'll change the value back to 0. Let's apply that. We'll cancel out of that dialog box. We'll rotate the screen around. And next what we want to do is we want to go ahead and drive that constraint. So we'll find it in the browser. We'll just right click on our mate constraint that we just applied. Click on drive constraint. And then let's go ahead and place in an ending value. We'll go ahead and we'll change that. And we can also go back and expand the dialog box. We can change in the number for the value. Let's change it to a 1/16 of an inch. And let's go ahead and run it through its range of motion. And let's run it back. And that's all there is to driving a mate constraint.